Hello and welcome to today's daily Leetcode challenge. Today we'll be solving question 1558. I'll be going through my thought process as I come up with a solution, then stick around for the end of the video where I compare my solution to the solution of others. Thank you. With that, let's begin the question. So, you're given an integer array nums, and the integer and an integer x. So in one operation, you can either remove the leftmost or the rightmost element from the array nums, okay? And subtract its value from x. Okay, so in one operation, if there is an array like this, we can either get its leftmost or its rightmost value and subtracted from some variable x that we also get as an input. Continuing, note that this modifies the array for future operations. So that means that once we've subtracted an element from either the left or the right portion of the array gets smaller. Cool. Return the minimum number of operations to reduce x to exactly 0, if possible. Otherwise, return -1. Awesome. So, in my own words, this question is asking us the following. Given a, let me actually choose a different color. Given a array, and as an example, we see arrays such as 1, 1, 4, 2, 3, and a value x equaling to 5, we have to pick out the correct number of elements from either the left or the right to eventually get x equaling 0. So let's actually go through an example of what that would look like in this scenario. Just for the human eye, it's very easy to find this right away. It seems like from the left, it would take us not even 3. We would need these numbers here, which we can't do without removing this element first. So what we end up having to do is subtract 1 from the left, equaling having 5 minus 3 going to 5, and then once again for x equaling 0. So in this first example, it would take us 2 operations, 2 subtractions from the right to get x equaling to 0. And so that's exactly what it's asking, right? So there's also an example where the output seems to be -1, which just means that there is no possible way that we can subtract any elements from the left or the right to get the correct sum subtracted from x. And then there's another example where we can do this, but in this scenario, it seems like we were subtracting elements from both the left and the right. And in this case, in particular, if I was to do this quickly, we have a 3, 2, 21, 1, 3, and an x equaling to 10. And let's see, the order here of what we subtract from the left or from the right doesn't really matter, but what is 3 plus 2 is 5, and 1 plus 1 plus 3 is 5, and that equals 10. So at some point we will be removing 2 elements from the left, and I'm just gonna denote this as two operations where x is now 5, and then two more operations, 2x equaling 0, right? Because the sum of this is 5 and the sum of this is 5. 5 plus 5 equals 0. Okay, so what is this question really asking? Well, it's if I was to remove the work here and actually remove the x, any number that we're trying to, any x that we're trying to get here on the right, whether it's 10 or 3 or 5 or another number, we're trying to do it with minimal operations. That means basically the minimum number of numbers being subtracted from this original array. And to kind of grow on that, minimum number of operations also just means minimum number of tries to get this number, right? So there could be situations where we just thinking there are many different combinations of ways that we can subtract from the left and the right, right? We could go first this operation, then we could go this operation, then we could go this, then we can go 4 and 5. So, but it seems like the order doesn't really matter as long as you're correctly picking the correct number from both the left and the right. And so, since order doesn't matter, I'm thinking, do we even care about like what if we find the rightmost possible position first before we exceed a sum here of greater than x? Like, for example, we clearly can't go into we can't have the sum equaling more than 10, right? So we could put a hard point here and then start maybe exploring these options here. What I'm really trying to get to right now is understanding that what we're really trying to find is some maybe like left bound and some right bound that will cut off this array into these sort of like, how do you say this? Basically divide it into at least two different portions. One, at most two different portions, one on the left and one on the right. Video cut out again, but nevertheless, we continue. What I'm trying to get to is there's a question that has many faces and that gets repeated a lot in different formats. But the question, and I'm gonna write it down right now, or a form of it, is the following: find a let's say find a subarray let's say minimum, or find a maximum subarray, contiguous subarray. So it also has to be non-breaking up, contiguous subarray of with elements sum of, I don't know, n. So basically, the question is find a minimum subarray, maximum subarray of elements in this input array. So it could be like a 2, 20, or a 22 and 1, 1, where the sum of elements in that is going to be equal to a specific number. If this at all is giving you any hints, it's because what you're really looking at and what you're really transferring this problem into is a question that is exactly this. How do we find this? How do we find this maximum subarray with elements sum of n? Well, let's try transferring this problem into something that would let us solve this. We have we're given all of the numbers, right? We're given numbers 1, 1, 4, 2, and 3. And we have to find what boundaries from the left or the right are equal to this number x5. Well, to transfer it to this problem, I could say that now my new x is going to be just the x is the sum of nums minus x, minus the original value x. What is that going to give us right away? That's going to shift our focus to, instead of trying to find the outer bounds, to finding the inner bound, right? It's gonna kind of switch context. It's gonna ask us now to find the innermost or subarray rather than two disjoint subarrays. And once we make that modification, another switch, right, is originally they had here find the minimum number of operations to reduce, and minimum number of operations just meant a minimum number of the minimum subarray, or the minimum number of elements in that array. Well, we can switch this to being the maximum. And what does this result in? This results in a question that basically is this. Find a maximum subarray. Find a maximum subarray with elements there we go. Find a maximum subarray with elements sum of n, where n is actually now just x modified a bit. And let's see, yeah, x. Cool. So yeah, enough talking. I think I made sense, at least in my head. Let's get to coding. We might go to the place where I shine. So to find the maximum subarray of size sum of nums minus x, first we have to update these values, right? So x now goes, let's say target x is just going to be the sum of nums minus x. That's what we had before as the new x. We're going to say that the length is just the len of nums. And now now the regular approach to finding the maximum sliding window, right? Left is equal to this. The current sum is also equal to this, and the max len that we care about maximizing is also equal to 0. And for right and num and enumerate nums, now I just go car sum. Now the job for me is to move the right cursor as much as I can until I exceed the number that I am targeting for, until I exceed max target x num. And so while current sum is less than or equal to, while current sum is less than or equal to while current sum is actually equal to target x. I see. So, sorry, pardon me. This loop already takes into account iterating and moving the right cursor one by one to the right. But there are scenarios where we end up having current sum exceed our expectation, right? So, and it could be that if we find a number that exceeds the target sum, the target x, we have to then start moving the left pointer up and subtracting from the left pointer those values that we've moved our window from. So while current sum is greater than or equal to target x, and left is less than or equal to right, I'm going to say current sum minus nums left, and left is plus equals to 1. Now, let's see, 1 second. If current sum is greater or equal to target sum, so we actually just want this. And then finally, if current sum is equal to target x, then max len is equal to max len right minus left plus 1. And this would leave us at a situation where at the end we have the max len if the sum overall, if max len does not equal 0, else -1. Except what we want here is the L minus max len. Cool. Awesome. We do want one more thing. There's an edge case where the sum, basically we have to include the whole, all of nums in here. And for that to happen, if target get x is equal to 0, target x is equal to 0, return L. Awesome. Cool. Yeah, and so there are a number of sliding window questions that are just phrased differently, or maybe approach it from a slightly different angle, but they still have the same approach where you have 2 pointers, and it's called a sliding window because it's constantly sliding. You're either increasing it or making it smaller. You're either increasing it by moving the right pointer up, you're decreasing it by moving the left pointer up, and then obviously it's shifting. And so I don't think there's a point to compare it to anything else because this is pretty much the standard approach. So with that, thank you for watching, and I will see you later. Bye.